Hey, welcome back to math. So in today's lesson, we're going to talk about a tool, a math tool that's very handy for you. It's called the multiplication chart, or the times table, as we used to call it. And this is an organization of the numbers. You have numbers going down the side and across the top that are the factors. And in the middle, you kind of do a battleship game thing to figure out what the product is of those two. And this is a great tool for figuring out multiplication and division problems. And there's a lot of cool tricks you can do with this too. So let's learn a little bit about the multiplication chart.
You can use a multiplication table to help you find patterns. How can you explain patterns in the multiplication chart? Think about this question during the lesson. Yolanda noticed that 4 times 6 is double 2 times 6. How can you explain this? How is 2 related to 4? What is the same in the facts 4 times 6 and 2 times 6? 4 is equal to 2 groups of 2. In both facts, 4 times 6 and 2 times 6, one of the factors is 6. 4 is the double of 2. So 4 times 6 is double 2 times 6. Properties can be used to understand a pattern and to find out if the pattern is always true. You can use the distributive property of multiplication to explain why 4 times 6 is double 2 times 6. What does the distributive property of multiplication say? The distributive property of multiplication says multiplication facts can be broken apart into the sum of other multiplication facts. Which is a correct way to use the distributive property with 4 times 6? Use the distributive property to explain why 4 times 6 is double 2 times 6. Look at the two highlighted rows. The product of any number multiplied by 4 will be double the product of that number multiplied by 2. How can you use the distributive property to show that this pattern is true for other products that have 2 and 4 as a factor? You can show that this is true with other facts, such as 4 times 9 is equal to 2 times 9 plus 2 times 9 is equal to 18 plus 18 is equal to 36. Now you know how to use the distributive property to explain patterns in the multiplication chart.
Good job!
Okay, so today we're going to talk about a new tool. A tool is something you use to help you get something done. And in math, we've got lots of them. We talked about that. Here's another one, the multiplication table. And this is an arrangement of numbers. It kind of looks like a 100s chart that maybe you used in kindergarten or first grade or second grade. But you notice the numbers don't go in order. They do on the top, and then they jump back to a 2. And this is used to help you find the answer to multiplication problems. You can find a number here. Let's say you want to do 3 times 7. Well, you'll find 3 on the side and 7 on the top. And kind of like the game Battleship, if you've ever played Battleship. You take your 3 and your 7 and you go across to where they meet. And wherever they meet, that's your answer, 21. Another example, if we want to do, let's do 6 times 9. So we go to 6, and we go to 9, and we go across and down until they hit at 54. Now this multiplication table and the way it's set up can really help you, and it's got a lot of neat little tricks and patterns, and we're going to look at some of those in today's lesson. So let's erase this and get this out of the way. And we'll look at the book. So this is what they were talking about in the video, where you look at the row of the 2's, and they count by 2's, and you look at the row of the 4's, and that the numbers here are basically double the numbers here. Because remember when we learned our 4s, we talked about how 4s were just a double of the 2s. And so you see that here on this, and they highlighted it here to show you too. Okay, and it brings in the distributive property, because you can take that 4 and distribute it into a 2 plus a 2. So you got 2 times the number plus another 2 times the number. Let's look at the convince me. Look at the highlighted rows of numbers multiplied by 2 or 4. What pattern do you see across the rows? Well, we've got a 2 here and a 4 and an 8, 6 and a 12. So hopefully what you see is that the row of 4s is double the row of 2s. And that's a period at the end of my sentence. All right, let's jump up here to the guided practice. Do you understand? Do you understand? How are 3 times 7 and 6 times 7 related? Well, 3 times 7 is 21, and 6 times 7 is 42. So we're looking at 21 and 42. What I know about that is that 6 times 7 is 42. That's double. So 6 times 7 is double 3 times 7. Because 42 is double 21. In the table on page 238, is the pattern that Yolanda found also true for factors that are multiples of 3 and 6? Now, Yolanda's pattern she found is that the row of 2s, or the row of 4s, is double the row of 2s. And what I just told you is that the row of 6s is double the row of 3s. We got 3 and 6. We got 6, and double that is 12. 9, double that is 18. So is the same pattern true? Yes. The row of 6s is double the row of 3s. Okay. What pattern do you see in the columns and rows that have zeros as a factor? What pattern do you see in the columns and rows that have 0 as a factor? Well, you'll have to jump over here to this one to find that out. So here are the zeros on a row, and here is the zeros on a column, and always the response is going to be they are all zeros. So they didn't even put them on here, and a lot of times you won't see that on the multiplication chart. The little one that I showed you here also didn't have it because anything times 0 is 0. So we know those already. Explain why this pattern. I just answered that question. Why is that pattern true? Because any number multiplied by 0 is 0. Okay? So that's why you a lot of times will not see that. Use this chart here. Look at this chart. We're looking at patterns on the multiplication chart, the times table, the multiplication table, whatever you want to call it. Another tool to help you get these answers.